See, for example, you are studying in the BTech, okay. For you, why you are going for the higher studies? For your better placement, something better knowledge purpose, you are going for the higher studies. The similar way, you have to go for the 2G to 3G, 3G to 4G, 4G to 5G, 5G to 6G. Okay. Every spectrum, you have to changes from the 2G to 3G, some advantage will be there. 3G to 4G is some advantage will be there. And 4G to 5G also some advantage is there. And 5G to 6G also some advantage will be there. So coming to the point of the 4G to 5G, that is a use change will be there. Okay. The 4G generally are using that is the LTE system. That is also called an LTE system using the one of the modulation scheme, that is the OFDM. That's very famous. Still no 5G, 6G also using the same modulation scheme. That is the OFDM. You all of you know here that's called OFDM. Orthogonal frequency mix and multiplexing exists. No. Okay. So from the going to the 5G, its name is called as 5G NR. I'm not here. Because like so NR is given. 5G NR. What is NR? New radio. The 5G NR means new radio. So what is the meaning of the 5G NR means new radio? Why is additional is calling? Previously 4G is there. There is no NR is there. Only 4G is called. Next we'll be going to 5G. 5G NR is added. NR means new radio is added. Why the name is coming? So in the 4G you are using only one subcarrier space. That is a 15 kHz subcarrier space you are using, and 20 Mbps bandwidth are using. 20 megahertz bandwidth are using. Okay. But going to the 5G. So you are going for the new radios. So it is applicable for the 15 subcarrier spacing, 30, okay, 30 to 60 kilohertz, 120 kilohertz, 240 kilohertz, 480 kilohertz. These are the things is applied. Means a very simple thing. For LTE system, you are using only subcarrier spacing is 15 kilohertz. For 5G, you are going, so you can use 15 kilohertz, 30 kilohertz, and 60 kilohertz, 240, like 480 also going. So what is the decision? Why you are going to the 15 to 30, 30 to 60, 60 to 120, 122, 240, 480? These are the required. Yes, definitely is required. Madam says that the higher data is required. Then you have to go into the higher subcarrier spacing also required. Clear? So that's why the name is called NR. NR means it is supporting the all subcarrier spacing compared with the 4G. So that's a major difference of the LTE system, that's 4G to 5G. So next thing is in 5G is held at the 2020. So in communication point of view, the what is there? That is the 3GPP is what you are using in industry point of view. 3GPP means third generation partnership. Okay, all companies is given the proposal. Who are the companies? Qualcomm, Broadcom, MediaTek, all of the top companies will give the some suggestions. The suggestion all of the stored in the one spec. Okay, that's the specification. Is called a spec. Is called a specification. The specification is called a 3GPP. Is called 3GPP means third generation partnership. In the 3GPP, what happened? All companies give some proposal that will be stored in the 3GPP spec. So every company, any other companies will be building the 5G. So definitely you have to follow the 3GPP specs. Like you are for easy student, you have to read the key subject only for easy, but given the government. Okay. Similar way, you have to any world, you have to design the 5G system. So you have to follow these are the specifications. So that is what these are the shown in the 3GPP spec. Okay. So these will be designed by all the companies, top companies like Qualcomm, Broadcom, MediaTek, so many companies is there. Okay. These will be the distributed. Okay. So in the 5G, what is the major points is the one is the eMBP. eMBP means massive data rate. Okay. The data rate will be supported up to 100 Mbps data rate is supported in 5G. So, and coming to 6G is called a immersive communication. Okay, immersive means the use data rate is required for the 6G. Okay, so then what happens is 100 times will be increase the data rate. So what is applications? Why these applications will be required? So these applications will be required for the higher video editing, augmented videos, some games, okay, virtual reality purpose application. These application purpose you require the higher data rate. So in the 5G is dependent eMBP, but in 6G is converted into the immersive communication. That's the one point. Okay. Next point is URLC. That is our latency point. If you do any work, in required some latency will be there. Okay. In the latency for the 5G is of 1 millisecond. Okay. So in the for the 6G is of 0.1 millisecond is required. Okay. So very low latency is required. So why the latency will be required means, for example, you have to design the vehicle, autonomous vehicle. So if any obstacle is coming in front of your vehicle, then it will be detected Okay, then apply the application to the brakes. The brakes will be applied. Everything will simultaneously applied. So with low latency purpose, in all the what are the devices will be there. This device is always active. So it prepares the low latency. So that purpose you have to work on the for 6 is hyper reliable low latency communication. Okay. Second point. Third point in 5G in 2020 is defined massive connectivity. Massive connectivity means so one device is connected to the all 100 devices simultaneously it works. So that is a massive connectivity. So that is defined in the 5G, but going to the 6G, that MMTC is converted into massive communication. That is called as 6G. So how much equipment, how much devices we connected means 100 times. For example, in 5G it depends 100. For 6G you have to connect to the 1000. So these are the parameters. So only difference of the 5G and 6G is these 3 points. Along with the 3 points, another 3 points is also included. That first point is ISAC. ISAC means integrated sensing and communication. I will tell you what is integrated sensing and communication. And next one is AML. So morning session one candidate asks me the question. So where you can use the AIML in the 6G. Okay. So AIML okay. So you don't know, you have some layers will be there. Physical layer, MAC layer, these are the layers will be there. You are studying in OSM model or not, I don't know. But in OSM model, you studied different layers will become. So especially wireless communication doing the physical layer. So physical layer, what happened means, so physical layer we can apply the AIML. And MAC layer also you can apply the AIML for the scheduling purpose point of view. Okay, I'm not discuss much more. And next thing is the ubiquitous connectivity. So this is also involved in the 6G. So ubiquitous connectivity means, so it can be connected to the entire world. How will be connected to the entire world? Through satellite. So that is called the terrestrial networks and non-terrestrial networks. So both the combination. It is required non-terrestrial networks. Anyone? Is it required or not? This is sufficient. Rural area, urban area is covered in one city, one country is covered. But why you are connected to the one country to other countries? Is it required? Yes, it required. For example, if you have any disasters is happening suddenly, so the terrestrial networks all of the products, how will be communicated? Sir, okay, for example, you have to take some area, X area. There's floods is coming, so all the towers will collapse. Then how will be connected? So through satellite you can connect. So these are the three parameters. EC department, sir. That's so this all will be coming at the 2030. The target is 2030. Color mic. So 2030 will become the 60 completely. So including of the 5G as well as will be there 5G as well as can include the another 3 points. I said another is the AML and as so we connected the all over the world. So next slide. Yeah, coming to the basic communication structure, how we can be achieve these all the things. Above mentioned things, how we can achieve. So basic communication, all of you know in the basic digital communication, one theorem is there that is called as Session2 theorem. Yes, everybody knows. C is equal to log of 1 plus H. H means this is channel. P is the transmitted power. This is the noise. Everybody is here this one. So all the communication, we are designing any modem, anything. So based on this formula only. Okay. So C is equal to log of 1 plus H P into sigma square. So for achieving the high capacity, for example, you are achieving the high capacity, then what happens? You are studying the capacity formula, you have 5 marks, 10 marks question system, they can be good. So C is equal to you have to calculate capacity, everything. So then what you will achieve? Capacity get higher, then what you do? What will we do? So simply I will explain the MATLAB clearly. So what is the major advantage of the capacity? Are you seeing the screen? Everybody? So previous formula you have remembered, log of 1 plus SNR. SNR means channel into power by noise. Signal to noise ratio. Signal to noise ratio means transmitted power by noise power. Agree everybody? So for example, I have received a 12 SNR dB. Okay, then I will calculate the capacity. So for example, 12 SNR, then what is the capacity? So just I run. How much capacity you get? Around 4 bits per hertz. Clear? See, here is a 4 bits per second per hertz. Yes, bps per hertz. Got it? So before this capacity, I will introduce some basic things. Already you know everybody. QPSK modulation everybody knows. QPSK 16 form. No sir, no. Yes sir, no. Tell me, yeah. Yeah. Again, any other modulation? 64. Any other modulation? 256 form. What is this meaning? Can you tell me? QPSK means what is the QPSK? Okay. What is lovely, yeah. Some active purpose. This is not exam. Okay. QPSK means? Yeah. QPSK means official modulation means nothing. Two symbols at a time you have to transmit it. Okay. So this is a very important session for you who are attending for the interview for that Qualcomm and Broadcom, like in the communication department point of view. Okay, this is very important. Basic questions will be asked. Same questions will be asked. What is a QPSK means? QPSK full form, you don't tell me. Okay. Initially rejected. No second round. Okay. It will be, yeah, everybody knows the constellation diagram. Yes? This is the constellation diagram. 2 bits at a time you have to transmit it. What you will transmit? 1 1, 0 1, 1 0, 0 0. Like this. Agree? So 2 bits you have to transmit it. Okay? So 64 means how many bits? Yeah, again thinking, huh? PSK means 2 bits at a time you have to transmit it. INQ. Okay. 64 means? Yeah, 4 bits. 4 bits you have to transmit it. 64 means? How will you calculate these are the things? Huh? How will you calculate these are the things? Log 2 of m, you do not remember this formula? No? M is m count. We can substitute here m. Log 2 of m. Okay, 16 means you have to substitute it. 4, then 64, then 256. And right now, currently, Wi-Fi is working on the 1024 form. Okay, for higher data rates. You have to remember that. Okay. 1024 is working right now. Okay? Okay, that part is given. You have to read these other things. Okay, then you have to get the 4 bits per second. Means you have to choosing the 4 bits at a time. You have to capability is there in your hand. You have to transmit is 4 bits at a time. So 4 bits means which modulation scheme can use? Which modulation scheme you can choose? 16 form. For my hand, I have the bandwidth is, I am the vendor, so my system will be supported, 100 Mbps will be supported. Agree? So 100 Mbps, sorry, not 100 megahertz bandwidth will be supported. Is it clear? My system is 100 megahertz will be supported. So this is 100 megahertz. Okay? Then you can multiply with the 100 into this capacity, how much? 400. Then what is the unit becomes? Mbps. So you will be supported how much? 400 Mbps. So this data rate will be supported. Your model will be supported. Clear? So very simple logic is, if you can achieve that capacity can multiply with the data rate, then it is give the data rate. Sorry, what you are achieving the capacity, that capacity have to multiply with your bandwidth. That is called a data rate. So right now everybody knows now 100 Mbps data rate also. So what is the meaning is? So downlink and uplink speed you have to calculate it. So how will we calculate the speed? So this is the formula. So coming to the question. So morning session, our vice principal has said that you are so many numbers will be there. Okay, but you are not getting the proper signals. Why? So in the 5G, one of the advantages is generally using the AMC, adaptive modulation schemes are using. If you observe any time, while you are traveling the train, you are watching the YouTube in mobile. Okay, the vehicle speed will be going on. Some part we have to run in 100 km speed. So what happens if your YouTube will be browsing, is rotating, speed will be down. but your voice call will be running. If you call, then voice will come in. Then how it's happening, you know? For example, you are staying outside, your net is working, your mobile is working properly, you are entering to the colleges, then your mobile will be the profile will strength will decrease. You can observe why this is happening. So these are all the things will be depending upon your SNR, signal to noise ratio, your receiver signal. For example, you are staying outside, there is a perfect line of sight. So line of sight means your transmitter receiver is a direct path will be there. If you enter into the room, so here is so many obstacles will be there. Okay, so then the signal can't be reached to your phone. So this is a non-line of sight. So non-line of sight, what happened? Your signal to noise ratio will be decreasing. SNR will be decreasing. Then SNR will be decreasing means your capacity will be decreasing. Your capacity will be decreasing means your data rate will be decreasing. So your data rate decreasing means you are choosing the low modulation scheme. That is the logic. And 5G is working on an adaptive modulation scheme. So according to your SNR, you calculated the capacity. After the capacity, you can choose the modulation scheme. Clear? So for the same example, I will put that 5. SNR will be, this is the worst condition. I am entering into the room, so my device is received the only 5 dB. Okay? Then tell me, what is the capacity here? What is the capacity here? 2. 2 means which modulation you can choose? UPS scheme. So 2 into you are getting the bandwidth is 100 megahertz. Then how much bandwidth will be supported? How much data it will be supported? 200. So then what you are observing, these are the things according to your SNR. Okay. Then you have to choose the adaptive modulation scheme. For example, it is become to 8 more than that. Then which modulation scheme you have to go in? Higher modulation scheme. So 64, 256, 1024. Yes. So why you are all companies will work for the design for the 1024 means why you are going? So it will be support for the higher data rate point of view. So you need a higher data rate, then you have to go for the higher modulation schemes. Are you got it this concept? This is now. Any doubt? Any doubt? No doubt. Very good. Yeah, that another question you ask. I have doubt. You get the 2, okay, no problem. I get the 4, I choose a 16 form. If you can go choose another, no problem. But in between getting 1.5, which modulation scheme I choose? You can use brain, man. You can ask the questions. So your own figure is coming, there is no problem. 2 means you choose for the UPS scale. 4, then you can 16 form you can choose. And another any number you can choose. But practically it's possible. Always possible. For example, I receive only 1.5. My device receives 1.5. Then what to do? Which modulation scheme you use? So in communication, Samina is only written, you can transmit 2, 4, 6, like this is given, not for the 1.5. So if you can issue then 1.5, then how can we transmit it? Already you know, but think. Then it was an answer. There was 80 people. Under sleep mode, active over. What to do? Very simple, man. 1.5 need 2 chair and price. That's the logic. That is a LPC. Coding techniques, you don't know convolution coding. I don't write a lab convolution coding. You're doing the convolution code or not? Yeah, okay, no problem. So then you get 1.5. Yeah, answer what you get. 1.5 bits per answer. I got it. This is your step. Then what to do? I mean, multiply with the 3/4 quoted. You have 1/2 right? 1/2, 3/4. Like this quoted will be there. So what is the meaning of the 3/4 quoted means? Every 3 bits, I add a 1 bit extra. Means it becomes a 4. Then if you can multiply with the 1.5 into 4/3 reverse, then what will happen? It gets a 2. It achieving 2. So 2 means which modulation scheme you can use? Similarly, if you are not getting any round figure, round number, then what to do? We go for the FPC. Okay, forward error control coding. That is called the convolution coding. This is not new words. All are the same words. Okay, in the digital communication, 5G technology. Clear? So, what is this idea? Concept is understood. So, In 5G, whatever mobiles is there, this all mobiles is working on the basis of your signal to noise ratio. So morning session, the sir was asked the question is that why not getting the proper signal? Voice call is not proper, data is not proper because of you are not receiving the proper SNR. If you receive the SNR at least 5 dB, then you can be QPSK modulation, it works. More than that, you can go for the 16 form. Like this is up to in 5G will be supported 256 form. Clear? So how much bandwidth will be supported means 100 megahertz bandwidth will be supported. For 4G will be supported only 20 megahertz bandwidth. For 5G will be supported for 100 megahertz. So then how much data rate will be? Means 5 times will be multiplied. Clear? Then what is the modulation schemes will be increases up to LTE system will be supported 164. But coming to the 5G, NR will be supported on 1024. For going for the 6G, it will be scored the 4028 modulation scheme also. But one thing is, if you can go in the higher modulation scheme, then you know the problems in more mode. For the demodulation is very difficult. So that is later next concept. Okay, can you skip that one? Are you got this concept? Everybody, then move to the next concept. I answer the partially answer why the signal is not coming. So you are understand the signal to noise ratio is not getting properly. Then what I do for achieving better signal to noise ratio? I can use any one of the techniques. Modulation scheme or any techniques I can use. Then can you improve the signal to noise ratio? Then how the signal to noise ratio improve? By using of the RIS. Okay, reconfigurable intelligence analysis. I will discuss that point. So next coming to the point. So what you will understand from this formula? So you get a better capacity, then you can be modulation, higher data rate will be supported. So for the higher one, will be depending upon the channel only. So these are the techniques are implemented basically. Okay. For the 4G, 5G, these are the major techniques are using. For beamforming technique, power control technique, adaptive modulation. Just now discuss the adaptive modulation scheme and massive MIMO communication. What is the beamforming? Just I will discuss beamforming. So everybody knows if you have transmitted signal X, okay, I transmitted signal is X at the receiver Y. So can you write this equation? Y is equal to Hx into noise. Everybody knows this basic communication. What is a Y? Received signal. What is a H? Channel. What is X? What is X? I am transmitted signals. What is this one? Noise. So what is the beamforming technique means? Y is equal to Hx plus N. What is our ultimate goal in from this equation? What is our aim? We want to H. We can extract H. So I can use some technique that is called a beamforming technique, that is called zero forcing and MMSE technique. Okay. So what is a beamforming technique means? H I know. How I know? I will tell you later. Okay. First I know the H. Clear? So while I am transmitting the X, so this is the channel. I know the H. Okay. So before this X, before transmitting this X, I can multiply with some equation. That equation is called H admission H inverse H admission H. Got it? This is zero force equation. This is a mathematical equation. This is called a zero force equation. It is all of the equation depending upon the H. H admission means H transpose only. If you can matrix will be there, you can use the admission. This is a mathematical logic. H admission H inverse H admission H. So I can multiply what I am transmitted signal. I know the X signal. I am the transmitter. Okay. So you are the receiver. So before receiving, I will transmit this signal X. I will multiply with this factor. Okay. So what happened this factor? X. Clear? Then coming to point, Y is equal to H plus noise. So I'm transmitting zero forcing into transmitted signal. Just I can put this equation here. What is the equation? So complete equation becomes H admission H inverse H admission H into X plus noise. Agree everybody? Get it? Then what about this value? What is this value? This is mathematical. H armation H inverse H armation H into H. What is this value thing? 1. It is inverse. Simple math gaya. X into 1 by X. X into 1 by X. How much? It is also similar. H armation H is inverse. H armation H. How much? What do you get directly? This is 1 means this one, 1. Ultimately, what you want? X. Get X. So this is the thing. So in the 5G also using the beamforming. So it will be question number 1. So H is called a channel. How to know transmitter? How will we know the transmitter? Before transmitting the signal. So how will we know means if you're transmitting the data, okay, before data you can add some pilots. Is it clear? The pilot is called a QPSK model. QPSK, BPSK. That is a one sequence. For example, I am the transmitter, you are the receiver. First I transmit the pilots. The pilot is a QPSK. Clear? So you already know that is a QPSK scheme. So I am transmitter Y is equal to HX plus noise. X already know at receiver side. Clear? Then I calculated H easily. Like X also. So then calculate H, whatever the H value, Y by X. That is the channel. That is called a channel estimation. So many papers, so many things, IEP, everywhere we show the how to estimate the channel. So channel you can get, once you can estimate the channel, then while you transmit my information, I do the beamforming. So I know the channel estimation, then beamforming, then I can get the exact X value. So that is what working in the 5G technology. Got it? And next technology is power control. So while you are transmitting more power, then you can get the more SNF, but it is complex. Okay. Next is the adaptive modulation scheme. Already know what is adaptive modulation. Based on the SNF, we can choose a modulation scheme. So these are the techniques is called use it MIMO. What is the maximum? Is I'm not discussing much more here. Maximum. So maximum means number of antennas increasing. Transmitter side and receiver side. Clear? Very simple thing. If one transmitter antenna, receiver one antenna. Okay, I'm transmitting only X. Then how much information we getting? Only X. If more number of antennas will be there, what is not working properly? So I'm transmitting 2 antennas instead of 1 antenna. Receiver will be receiving the 2 antennas. Clear? If any blocks will be there in between. So okay, antenna failure and then what to do? So successfully you receive the signal. So that is a concept in the massive memory. The capacity will be increasing n times. How many antennas are using? But one of the drawback is that so more antennas you are using means more RF chain is required. So more power consumption is required. Okay, in the 6G the mainly target is energy peak consumption is there in 6G. So low power you can use in the 6G. So this is also not working. Maximum is not working. Because of another problem also there. Self-interference is forming. Antenna to antenna. Here I am using 4 antennas. Okay, 4 antennas will be transmitting. Before transmitting, here is the self-interference will happen. The same signal interferes with this antenna. This antenna will interfere with this antenna. This antenna is interfered with this antenna. Then overall interference will be happening. That's why we are not using the MIMO system, massive MIMO. But in 5G, we are using the massive MIMO. That is also maximum antenna will be supported 64 practically. Okay, so that's the MIMO. So these are the techniques, existing techniques will be there to enhance the capacity. Is that no? But in 6G is not sufficient. You cannot achieve these other parameters. So you want to require some more new techniques will be required. So that is the new techniques is RIS. This is called as the RIS, that is reconfigurable intelligent surfaces. This another name is called a IRS, intelligent surfaces. Okay, IRS. Why this is a preferred, everybody? So why this is a preferred means? So see here, this is the RIS structure. It consisting all of the passive elements. So you know what is the passive active? Passive means there is no power consumption required. Active means you have to give some power. Okay. For example, you have the amplifier is there. Amplifier is required, some power will be required. Okay. If you can put the one mirror, it reflected, there is no required any power. Okay. So RIS is made up of low cost of passive elements. The first thing. Second thing is you can be controlled in the desired direction. Okay. For example, this is a reflector, for example. Okay. This is a reflector. This is the TX. This is the RX. Agree? Okay. I am transmitted to TX to reflector. So you can see the clearly observe this. This is our access point. VP means access point. This is the all the signal will be reflected in the RS panel. So this all point will be user is here. Okay. But is it reflected in this position? What happened? This is a restrictive nature. But I will design such a way that is a constructive way. So where the user will be there, I will add that every point to the user side. That is a constructive way. So I am such way that I design this RIS. This signal is completely transmitted to the user side. So it will be getting the better SNR. Agree or not? So what happened? This is the access point. This is the user. In between the any obstacle will be there. There is no direct path link will be there. Then what happened? The signal will be incident on the RIS. RIS will be transmitted to the user. By that is also in the constructive way, not a destructive way. Just remember that thing. Then what is a constructive way? How will we constructive way? So that will be discussed in the slides. Clear? So are you know what is RIS? So RIS means it is surface. Okay? It having the n elements. The all n elements will be controlled by the one device, that is FPGA devices. So it will be in the constructive way of it is. Okay, not destructive way. See here, observe. User is one side is there, another is a dark color and dark red and plain orange color. Okay. Then that is first one is a constructive way, second one is a destructive way. Then how you have a question also. We can ask the question. How will we design in the constructive way? Okay, that will be discussed in that slide. So remember, RIS is constructed by the passive reflective elements and it is also reflected towards the desired direction in the constructive mode. So that is called the RIS. So this is the RIS architecture. It has 3 layers. The first layer is consisting of this is the first layer. This is a tunable element. Second layer is a copper black plate. Third one is a control circuit board. Okay. And it is also is a low cost because of just for the reflecting purpose using the pin diode. Pin diode costs how much? 1 rupee, 2 rupees. That's it. Pin diode can use, FPGA can use, director diode also using for the reflecting purpose. And then this is a control panel. So according to the access point, will be controlled where the user will be there. The position of user no, then the last block is the control circuit. That will be controlling the all the reflective elements. Clear? Increase only. Then I will tell you how we can increase. Okay, that's a good question. If you reflect in time, then how the signal strength will be increasing? Reflect how to get no, but how mathematics? I will put that in mathematics. Okay. So these are the major advantages. So after this slide, I will go there. Okay. What is the major advantages? First of all, it is a low cost. Clear? And it is easily implemented anywhere. It is like a tapper. Okay, for example, this room is there. Wi-Fi is not coming. I can put here in IRS. Then I get a better signal. Then how I get to? Later I will explain. That's the purpose. And compared with some operating systems will be there. I will not discuss much more. We have lack of time. What is the operator design? So this I will focus on the only completing the RS. How the enhance the signal to noise station. Okay. So next slide. So these are the advantages I will not touch. So coming to the point. So this is the TX and this is the RX. So in between TX and RX, some obstacle will be there. So what happens? The receiver will be receiving the signal through the RX. Let us assume. Okay. For example, if you have tower is okay, but railway station there tower is. Unfortunately, we did a big billion piece for 20-40 towers building gets. So then what happened? Obstacle in between the TH to receiver set. Okay. Then again another tower just one costly. It's very high cost. Then I put the RX. Okay. See, this is the instant signal. See, let us see from the TX to RS panel having the channel is H of n. Let us assume this H of n. N means nth element. Okay, this is H of n. It is reflected channel is G of n. Receiver will be receiver RX. For example, here is This signal is incident signal. That is incident signal is X. That is a bomb signal. QPS care 16 for what and maybe you can decide. This is X signal of transmitted. It will be incident on the RS panel. One RS panel is having the N reflective elements. I took only one element. That is a AFN element. It having some phase. E to the power of J theta 1. J theta 1. I will write this theta is what is the phase. I will tell you simple thing. All of you read the Fourier transform. It's very difficult. Fourier transform. I will ask one question, simple question. What is x of t minus t naught? Fourier transform. X of t Fourier transform is x of omega. Okay, x of t Fourier transform is x of omega. X of t minus t naught. Can you tell me what is the Fourier transform? This is a basic question. Don't know? Let's go. Very good, good ask. Agree? Yes or no? X of t minus t naught is x of omega into t to the power of j omega t naught. This is the phase. So this is the delay. If delay of signal in frequency domain, what happened? Phase. I'm writing here also. So some delays is happening. Okay. So then can write an exponential form e to the power of j theta n. So this is the signal incidented. Reflected. This is a reflector. One element. That element is nth element. Amplitude is AFN. Its phase is e to the power of j theta. So phase means is nothing but a delay of the signal. Got it? So then AFN into e to the power of j theta. First one element. Remember this is one element. So what happened? Incident signal is x multiply with the this is the phase and amplitude. Phase and amplitude into incident signal. What is the reflected signal is equal to AFN into e to the power of j theta into x. Agree all of you? Oh, what not interesting. Agree or not? How many elements is there in RS? How many elements will be there? Let us say n elements will be there. Then what happens? Reflected signal. N is equal to 0 to n minus n into a to the power of n into e to the power of j theta. N into incident signal. What is your incident signal? QPS x any signal. So then what happened? So we can say base station to RIS channel is h of n. From RIS to UD channel is g of n. So what is the reflected signal? X into h of n into RIS signal. RIS 90. So can you write this equation? Reflected signal is equal to n is equal to 0 to n minus 1 into h of n into a power of n e to the power j theta n into x. X is the my transmitted signal. So what is your getting the reflected signal? Reflected signal is from ear to ear transmission. What your reflected signal is? Agree it out. Simple mathematics. There is no any rocket science is there. Next, what is the complete channel at receiver side? What is the channel? H of n, G of n, H of n, G of n into all element phase amplitude. So n is equal to 0 to n minus 1, g to the power of n, h of n, a to the power of n, g to the power of e to the power of j theta n into transmitted signal. Agree? Got it or not? So y is equal to how much? N is equal to 0 to n minus 1, g power of n, h of n, a e to the power of j theta n into x. Completed. So next. See, let we took only channel. Okay, transmitter side signal you can lift left. Only I took the cascaded channel. What is the cascaded channel? N is equal to 0 to n minus 1, g of n, a to the power of n, e to the power of j theta n, h of n. You know Cauchy's inequality theorem in mathematics first year. Cauchy's inequality theorem. Mod of z is always equal to the less than of. See, you remember, I don't know, in communication also is coming, wireless communication now, because basic mobile communication across Cauchy's inequality theorem. Okay, so Cauchy's inequality theorem means the magnitude of signal, any signal, we can be decomposed into two times. It is always less than the original signal. Okay, so we can consider this is Z. Okay, I can apply the Cauchy's theorem. So mod of square is always equal to the, actually this is less than equal, or not equal, less than equal, then I can write the individual mod. So then what happened? N is equal to 0 to n minus 1 g of n mod a power of n mod h of n mod e to the power of j theta, all the phases. Theta n is the phase of RIS. Theta hn is the phase of base station to RIS channel phase. And theta g of n is the RIS to receiver phase. Agree? From this equation, this just I can apply the Cauchy's inequality theorem. Then tell me, when it will be the maximized? What is the condition? When it is maximum? If the power of 0 getting 2 pi it will be maximum. So when will be converted into 0 or 2 pi? What is the condition? Theta n is must be equal to the minus of theta of h of n plus theta of g of n. What is this one? These two things. This is the phase of transmitter channel and receiver channel. So my system is I know the phase. Then I substitute all the things. Then what happened? These all are the 1. So then g of n, a of n, h of n is a mod. Clear? So already we know the g of n, h of n, and a of n. The summation of anything that is always equal to the what happened? You can leave these two things. These two things we have to remove. Only have n is equal to 0 to n minus 1, a of n into 1. Then what is the solution? That is equal to n square. A of n is equal to 10. Let us assume that 1 unit amplitude, then it will increasing the n square times. So one slide is that. See here. Without IRS, my SNR is transmitted power H by sigma square. This is the SNR formula. If H is the transmitted through the RIS, then what is the H value? I can replace this one n square. Agree? From the equation, phase is the maximum. Then we can write n square. Tell me, this is SNR. How much increases? N square term is increases. Agree or not? So n square increases means previously without RIS, what is SNR? P by sigma square. With including IRS, how much? It will go to the n square times. So same thing I will show you in the MATLAB. Clear? So how will the enhance will take this? Okay. So just I will show you in the MATLAB. See, are you seeing the screen? MATLAB screen? Just I will walk through the code generally. See, m is equal to 4 means it indicates the modulation scheme. M is equal to 4 means it indicates the QPSK modulation. Okay. Then x is equal to random. So first initially I generate the random bits. After that I will do the modulation scheme. What is the modulation scheme I'm using? 4 means QPSK modulation I'm using. What is the transmitted power is 1. Okay. 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 Clear? See the code, everybody. So first what I doing? I am doing the X generation. X I am using the QPSK modulation. So how I generated? M equal to 4. First I will generate the initial bits. After that passing through the COM function. I am using the COM function. That COM m is equal to 4 means it generated the QPSK modulation. QPSK means it will be the, what is the QPSK modulation means? You know what is the values of QPSK? 1 by root 2, 1 by root 2. Don't know? Okay, I will show you here. See here X generating the all the QPSK modulation. Okay, after S, no? Yeah. See, what it? These are all the 0.7071 means 1 by root of square root of 2 value. Okay. So in the QPSK modulation, you have to remember this constellation diagram. First point is 1 by root 2, 1 by root 2, ILQ. Here is getting the 1 by root 2 minus of 1 by root 2. Here will be at the 1 by root 2 minus of 1 by root 2. What is the 1 by root 2 value? See, 0.7071. First value you can observe that. Minus 0.701 minus 0.701 is which coordinate? Which coordinate? This is the coordinate. Similarly, you can show these all are the map. All of the input bits is mapped in the form modulation. Okay. So after this form modulation, I am multiplying it in the transmitter power. Here I took the transmitter power is 1. Clear? Then coming the point. So I am transmitting the both the IRS without IRS also. So see, blue color is the indicator without IRS, means N is equal to 0. So what is the BL? And I am sending the transmitted power is 50 dB. How much bit error will be coming? 10 power of minus 1. What is the meaning that bit error? You know bit error means? For example, I am transmitting 100 bits. Receiver will be receiving only 99 bits. How much bit error will become? 10 power minus 1? That is a bit error. Okay? For example, transmitter will be transmitted 1000 bits. You receive the one error. Then how much bit error? 10 power minus 1 minus 2. Minus 2. Okay? Got it? See, with IRS, it will say SLR 50 dB. How much BR will come? 10 power minus 1. Adding IRS, then how much bit error will be coming? 10 power of minus 4 at 45. If IRS is doubled, means what happened? So IRS number of elements is increasing, then what happened? SLR will be enhanced. So BR will be the decreasing. From this example, you can observe clearly. So N will be increasing, number of reflecting elements is increasing, then your SLR will be enhancing. And if your SLR will be enhancing, means bit error rate will be decreasing. Next. Yeah. So before, I think 1 hour is completed. Before 1 hour, so I recap what we were discussing presently. Okay. So in 6C, we require on. No, what is any question? What ask any question from this? Right? Then definitely I will ask the questions. If not you ask her, then definitely I will ask. See, in 6 years you are going, definitely. Next generation will go. Okay? Still now you have to do any research from the TX side and RX side. Still now you have to not do any research between the channel. You cannot be do any research on the channel. Why? The channel is unpredictable signal like it. Similar channel also you can't do it. Okay. So the channel, how will we control it? The controlling device is called an RS. Okay. So by controlling thing, if you can phase will be controlled. Okay. Then your signal to noise ratio will be the enhanced. The signal to noise ratio will be enhanced means then it will impact on the BR, bit error rate. Clear? Okay. So first concept is clear. So for 60 you are going, then you have to prepare the better SNR. So better SNR by using of RS you will ensure. But what about the massive connectivity? Connectivity also you have to enhance. Then how will we enhance that one? So then we go for the another modulation scheme that is called here not written, that is a NOMA, non-orthogonal multiple axis. Okay? If you combine the RS and NOMA, then what you are satisfied? The rate will be satisfied as well as connectivity is satisfied. Who will be the what about the latency purpose? How will be the decreasing latency? So NOMA will be take care of the latency also. Then how will be latency will be take care? I will discuss the two things. One is how will be supported the NOMA for the massive connectivity and how will be supported for the low latency. Clear? So the three things will be achieved, then 6G will be worked properly. Clear? So let us go for the NOMA. So before NOMA, I will tell you what is the OMA. Okay. So listen clearly. Want to bake? Yeah, definitely. Okay, how much? When you expect it? 10 minutes. So next we'll discuss the